So before I get started, I want to say something because I think of the presentations I've seen so far, this is the only one that's looking at adult Braille readers, proficient adult Braille readers. And the reason that I do that is because I want to know what is it that proficient adult Braille readers are doing so that perhaps this can be translated into how children who are learning Braille need to be taught. I was very sad earlier today to hear about some of the statistics, particularly from Luis's study of how slow a lot of the readers are. And it turns out that the average reading speed in the group of 50 adult Braille readers that I studied is around 130 words a minute. So what is it that these proficient adult Braille readers are doing, and can we learn from them in terms of developing pedagogy and so on? But that is just an excuse to say why I'm looking at adult Braille readers. So I want to start out by showing you a famous illusion. Most of you have either seen this, or those of us who can't see it have at least read about it. This picture is called Rubens' vase, named after the Danish psychologist Edgar Rubin. If you focus on the image in the right-hand panel on this slide, when sighted people see this picture, they can see either two black faces looking at each other on a white background, or a white vase on a black background. Sometimes you'll see two faces, sometimes you'll see a vase, and the version in the left-hand panel helps foreground the vase so that it pops out and is harder to see the faces. I'm showing you this slide since this matter of perspective is relevant for this talk, since in short, focusing on Braille as a code may cause us to miss the perspective of how Braille is read and written by its readers. Are my slides working?
Yes.
Good, okay. I always have to ask my students that. So what is a writing system? A writing system refers to any conventionalized symbolic means of representing a spoken language in a non-ephemeral, non-auditory way. The two components of any writing system are, first, the script, the set of symbols used in the writing system of a given language, such as the Latin alphabet, the Cyrillic alphabet, Chinese logographs, Cherokee syllabary, and so forth. And second, the orthography, the conventional arrangement of those symbols into words, sentences, and larger units. English print, then, is a writing system to visually represent the English language, consisting of a script, the Latin alphabet and other Arabic numerals and other symbols, and the orthography, essentially how words are spelled and how punctuation is arranged. Braille is a tactile writing system that enables blind individuals to read, write, and achieve literacy. English Braille, or whatever language we want to talk about, but I'm talking about English Braille today, is also a writing system for representing the English language, except it does so tactually rather than visually. Braille has an alphabetic script based on a tactile 6-dot cell, and English Braille consists of two orthographies, uncontracted Braille and contracted Braille. And the surface spellings of many words are quite different across these two orthographies. Now, I'm skipping slide 4, which gives some examples of that. This is the first thing on the Braille handout is slide 4. We're not going to talk about that. Earlier, I just said that Braille is a tactile writing system that enables blind individuals to read, write, and achieve literacy, but a code-based, that's a writing system-based approach. A code-based approach to Braille would say something like this idiotically embarrassing phrase that I wrote in a published article in 2009. Quote, Braille is a rule-based cipher for converting an ink-print writing system to the tactile modality, unquote. Englebretson, 2009, page 69. I want to unwrite that. But I figure if I'm going to complain about other people overusing the code metaphor for Braille, then I'll start by complaining about myself. Okay, so if you get complained about, know that you're maybe in good company. And in everyday usage, of course, professionals and readers refer to Braille as the Braille code or just the code. But this code perspective is based in the experiences of sighted transcribers and teachers, not in the everyday literacy of those of us who read Braille natively. Here is Another quotation, the code-based perspective on Braille is clearly exemplified in the following citation from a recent, otherwise excellent psychology textbook on touch and blindness, co-written by the keynote speaker this morning. Sorry, Edward, if you're here. Braille is a very useful, tangible code for reading, writing, and communication for blind and very low vision individuals. Braille characters are abstract representations of letters, and they differ significantly from the shapes that they represent, unquote. Okay, there's a lot to unpack here. The authors explicitly state that Braille cells are abstract representations of print letters. In other words, the Braille letter T is not related to the print letter T in any concrete, tangible way, but more to the point, the authors are claiming that Braille characters represent print letters. In other words, Braille cells encode print letters. Braille is a code, a useful code. I'm glad that it's useful. And this is certainly true in terms of Braille, how it developed historically, and this is a consequence of viewing Braille as a code. However, this offers an incomplete picture of the relationship between the Braille and print writing systems for a given language, right? Both of which, in this case, represent the English language. This perspective obscures the fact that both print graphemes and Braille graphemes are actually abstract representations of phonemes. For example, in the print writing system for English, the print letter T is an abstract representation of T, in slashes is a phoneme, right? And in Braille writing for English, the Braille letter T is also an abstract representation of that same phoneme. Okay? So the Braille grapheme T does not represent a shape, it represents the phoneme T. So there's also, by the way, there's nothing concrete about the print grapheme T either. It could have been encoded by any symbol we picked. Print letters are also totally arbitrary abstract representations. All right, but enough on that. The key question for our concerns today is, do proficient Braille readers decode Braille into uncontracted print orthography in order to access sound and meaning? Or do proficient Braille readers read Braille on its own terms as a writing system, parallel to rather than dependent on the print writing system? In other words, is the point of Braille that it provides access to print, this code-based view, or is Braille, for its users, in and of itself, literacy? Now, before we can address this, we must first understand the role of sublexical structure in Braille reading. Okay, what is sublexical structure? Sublexical structure refers to the easily recognizable chunks comprising more than a single letter and less than a whole word. So complex graphemes like digraphs and trigraphs, syllables, morphemes, and so on. Fluent print reading relies heavily on the unconscious, rapid visual recognition of these sublexical units. The role of sublexical structure in Braille reading, however, has not been well investigated. Here is the citation for an article that my colleague Simon Fischerbaum and I recently published in Cognition. And I'm happy to, if you email me, I'm happy to send anybody who wants this article. And I'm going to talk about our findings now. So our subjects were 50 adult proficient Braille readers, and the relevant parts of our study concerned 2 reaction time experiments on lexical decision tasks to explore the 2 areas of research: chunking and morphemic awareness. So the rest of this talk sums up our work, and then I'll return back to this writing system versus code perspective issue. Our first question involves chunking. Is Braille perceived completely serially, cell by cell, one cell after another? Or do Braille readers show chunking effects? And to test this, we focused on 2-cell contractions in Unified English Braille. I won't go into all of the details of the experimental design and so on, but the question is, are 2-cell contractions perceived as a single unit, or are they read as just another series of 2 cells that happen to be adjacent in a word? And we borrowed an experimental paradigm from the print research literature that has asked the same and answered the same question for print digraphs. A digraph, of course, is a series of two letters, such as the OA in boat, that represent one phonological unit. It has been found that when a digraph, such as the OA in boat, is split by a distractor, people take longer to recognize the word than when the distractor appears either before or after the digraph. So we used this paradigm in Braille. As the distractor, we used two full Braille cells, like a crossout, and we called that, for our subjects, we called that the blob. And we predicted that if two cell contractions are read as a unit, then people would take longer to read the word when interrupted by the two full cell distractor, the blob, than is the case excuse me, when the blob goes somewhere else in the word. We used a lexical decision task. The subjects read a list of 120 words presented one by one on a Braille display. 60 of those words are actual words like clever, and the other 60 are nonsense words like plurt. We told the subjects that each word would contain this blob, and what they should do is to pretend that that blob isn't there and decide as quickly as they can whether what they're reading is a word or not a word. And they indicated their choice by pressing a foot pedal that was hooked up to a computer that timed the presentation of the words on the display, and then the exact millisecond when the subject reacted to it by pressing the foot pedal. On the handout, this is slide 13. Oops, no, it's not. This is slide 13. And so, for example, in one presentation block, you would read the word several, S.5 blob EAL. And in a different presentation block, you would read the word several as S.5E blob AL. So in the first condition, the blob separated the two-cell contraction. In the second condition, it occurred after the two-cell contraction. Okay, and these were all matched and controlled and so on. You can read about the experimental design in the cognition article if you want to know the full experimental setup. Now, what are results? This is a graph and statistics of the reaction times of people in each condition. Our findings basically are that subjects took significantly longer to react to words where the two-cell contraction was interrupted as compared to when the interruption was elsewhere in the word. So conclusions for this component of our study are: proficient Braille reading adults process two-cell contractions as a single unit, as a chunk. Two-cell contractions are special. They're more special than just two cells that happen to be next to each other in a word. If readers were decoding back to print spelling before recognizing these words, then we would not see these significant differences in reaction time depending on where the blob is. They should all be the same. So Braille readers are not decoding two-cell contractions back into uncontracted orthography. That was very clear from this experiment. The next part of our study, how much time do I have left, Kay? Okay, the next part of our study looked at morphemic awareness. Are Braille readers uncontracting words into print spelling before recognizing them? Or do Braille readers show evidence for sublexical structure that influences the recognition of words at the contracted level? The morphemes of English consists of stems and affixes. Bless you. Unconscious recognition of morphemes is called morphemic awareness and is crucial for reading as it leads to fluency and automaticity. So, for example, run is a morpheme in English. It's a stem. You see it in words like outrun, rerun, runner, running, overrun, and many, many others. So you recognize the stem run in all of these words, and that allows for, among other things, easy recognition of meaning and clear association among words. Same thing goes for recognizing affixes, recognizing the suffix in singer, runner, dancer, painter, teacher, and so on, or the prefix re in repay, rewrite, reclaim, redo, rerun, and so on. Our unconscious knowledge of word structure leads to quick form-meaning pairings. In print reading, this happens very quickly, very early in the word recognition process. And now here's where English Braille gets interesting, Unified English Braille especially, since contractions sometimes bridge the boundaries of morphemes. So all the examples, and this is slide 18 for the people who have the handout, all of the examples here from Unified English Braille. So if you compare the words repay and rerun, for example, in repay, both morphemes are easily recognizable in Braille, the prefix re and the stem pay. In rerun, on the other hand, neither morpheme is apparent in Braille because of the contraction of er. You can't access the prefix re, since the E is subsumed into the ER contraction, and you can't access the stem run, since the initial R is also subsumed into the ER contraction. So we read it as a whole word rather than a word composed of the easily recognizable prefix re and the easily recognizable stem run, because they're no longer recognizable because they've been bridged. And there's a few other examples of bridging contractions that lead to this on your handout. Redraw, which I always read as red raw, that's how it looks, and redo, which I always see as redo, and renew, freedom, mileage, and those are just a few examples. So at this point, some people say, well, you just decode the Braille word into uncontracted orthography, and then you read it that way. So in this view, Braille reading is all about decoding to uncontracted print spelling. But is this really what happens? So again, we used a lexical decision task where subjects read a series of words presented one by one on a Braille display. There were 60 real words and 60 matched nonsense words. In this one, there was no blob. Just decide as quickly as you can if what you're reading is a word or not, and press the foot pedal accordingly. 30 of the real words had contractions that bridged the stem and an affix, and thus obscured the morphological structure. So what did we find? Here is a graph and the statistical analysis. In short, subjects took significantly longer and made more errors when recognizing words with morphological bridging than they did when recognizing words with transparent morphology, where stem and affix were unbridged. So for example, the recognition of words like rerun was significantly slower and more errorful than recognizing words like replay, which have transparent morphology. Recognizing words like mileage, where it's bridged, the mile and the age is bridged, was significantly slower and more errorful than recognizing words like frontage, where the morphology is transparent. So what does this mean? It provides evidence, first of all, that Braille readers are not decoding to uncontracted print spelling. If we were, then the reaction times, again, would be the same, regardless of whether the morphemes are bridged or not. Okay, thank you, I'll do it. I'll talk fast. If you decode both repay and rerun and then access its meaning and pronunciation as a code-based approach would assume, then there shouldn't be any differences in reaction time. But that's not what we find. So people are not decoding contracted Braille into print orthography or uncontracted orthography. We're reading it as is. So to recap, our work offers experimental evidence that Braille readers are sensitive to sublexical structure. I'm glad we're sensitive about something. Two-cell contractions are read as digraphs, not decoded back into how they're spelled in print, or we wouldn't see the different reaction times that we have. Morphemic awareness is inhibited by bridging contractions. Again, we're not first uncontracting when we read, or the reaction times would be the same. The sublexical structure apparent in two-cell contractions and bridged morphology is a first step in evidence indicating that Braille readers are not decoding back to print or uncontracted orthography, but are reading Braille on its own terms as a writing system. Now, why might this matter? Well, focusing exclusively on the code metaphor perspective causes us to minimize, at best, or be completely unaware of, at worst, the fact that, for its readers, the purpose of Braille is not to give access to print, but the purpose of Braille is, in and of itself, literacy. To go back to the Rubens vase illusion that I started out with, it's seeing only the vase and not the human faces. It's that perspective. So if teachers primarily understand and experience Braille as a code, mapping from print, then they may, consciously or not, teach their students to be print decoders. On the other hand, if teachers intentionally conceptualize Braille as a native writing system, parallel to, equal to, and not dependent on print, then the focus of their work may better enable their students to achieve full Braille literacy. Here are my thanks and acknowledgments, and I think I made it. Okay.
To some questions in a second. Okay, confession time.
Uh-oh.
For years, I've called it a code. I mean, totally called this a code.
Well, me too.
I know. So Robert and I had a conversation about this, and I think actually I have to change my words, though I agreed everything you were saying about the subtle difference between, it's not so subtle,
no,
difference between those two things. So we have some questions. Over here. Yep.
Hello, Vivian Aldridge from Switzerland. With the question about the affixes, it would have been very interesting to have a control group from the United Kingdom where the affix bridging has been standard for decades. So these rerun, redo,
right,
and so on are new in the United States.
Some of it is fairly new. There has been bridging in English Braille American Edition as well, just not as extensive. But you're correct. It would be good to have a control group. And I also read contracted German Braille, Kurzschrift, and I love the morphological transparency that we have there. So I would love to run similar studies with readers of German Braille too. But sorry, I interrupted your question.
That's wonderful. I'd love to correspond with you about German Braille.
Okay.
Thank you.
Okay, good, thanks. Okay.
Yeah, it's from Denmark. A question, have you done any, I haven't really formulated this question to the end, but have you done any studies regarding when reading the difference that might be or might not be between reading uncontracted and contracted Braille at all? Are there any... Could you say anything about that? Have you done any studies about that at all?
Well, so in North America, the norm is contracted Braille, and to start out with contracted Braille in the as early as you can. So finding readers of uncontracted Braille would introduce a confound because that's not what people read normally. So that would be really hard to do in the United States and Canada. I know there was a study published, it was 1988, I think the author was Brute or something like that in Norway, who looked at the differences between Norwegian contracted and uncontracted Braille in terms of reading speed and space, and found that even in terms of reading speed, there was the contracted Braille readers were faster. But it's not been done in the United States or Canada because we tend to do contracted Braille from the outset, so we don't have any native readers of uncontracted English Braille.
Sorry, the microphone. No, I was referring not as much to the reading speed as to the process of decoding or whatever you could call it, deciphering or whatever you said before.
Yeah, we haven't done that.
No. Okay.
Other questions? Okay, thank you.
Thank you.
We'll take a quick break.